Lesson 9.7, Special Functions. In this video, you will learn to identify and graph step functions, and then identify and graph absolute value and piecewise defined functions. This is your vocabulary for the section: step function, piecewise function, greatest integer function, and absolute value function. Okay, so the first function that we're looking at that's new today is the greatest integer function. And so what this function does is it takes whatever's inside and it asks, what's the greatest integer that's less than this? So let's say I had an integer such as 1.5, right? I want to find the greatest integer value of this. So this is asking, what's the greatest integer that's less than that? And that's going to be 1. Okay, so remember, integers are like the whole numbers, but they can be positive or negative. Okay, let's see what it would look like even if I had 1.9. The greatest integer function still goes down to 1 because it's saying what's the greatest integer that's less than that. Okay, so if I were to say 2, like normally we would think this would round to 2, but 2 is greater than that. If I were to put in a whole number, 3, it just is itself. The greatest integer function just spits out whatever integer it is itself. So what if I were to look at a negative? That's where it gets a little weird. So if I think of negative 1.7, the greatest integer that's less than that is negative 2, right? Because this isn't going to be negative 1 because negative 1 is greater than negative 1.7 because we're talking about negative numbers. So with negatives, it kind of goes down to like what you picture in your mind as a bigger number, even though it's still rounding down because it's negative. Okay, and this is what this function is going to look like because let's do, like we said before, 1.5 has a value of 1. So if I went to 1.5 on my x and went up, my y value there is indeed 1. Okay, and then the integer itself. So if I'm counting 3 up here, like when I put in 2 and I get 2, then I can't count it down here, otherwise it would not be a function because it wouldn't pass the vertical line test. Okay, so if we're looking at this, the domain is all real numbers, right? Anywhere along this, the x is defined. Because like where it overlaps, it's only defined at one spot. It's still filled in at least one spot there. Okay, so anywhere you draw a line on this, it's going to hit the graph somewhere on x. The range, however, is just all integers, right? Because I can't draw a line everywhere along y and hit it. So like if I were to draw there at like negative 1.5, there is no y value that gives you negative 1.5. They're all integers. So the domain is all real numbers and the range is all integers. Okay, so we want to be able to graph these. If you remember when we were doing the absolute value functions, if I had something like x minus 2 squared, this would take the graph of x squared and move it that way. It's the same for absolute value, so this, or the greatest integer. This is going to take it and move it 2 spaces. Not that way, sorry. I lied. Minus 2 moves it forward 2 spaces. So it's going to move it forward 2 spaces. So if my regular greatest we were just looking at, if that one normally starts here with a filled in circle and goes here open circle and follows this pattern such as that, when I graph this one here, moving it over 2 spaces and moving it over 2. So it becomes here like this. And so then I get filled in circle and I just keep going up. Okay, and you would continue it down as well. You could also do this by looking at a table of values. So if you wanted to try and put in some values, you would see that it works. So like for negative 3, we would get negative 5. So if you put in negative 3 into this, negative 3 minus, negative 2, you're going to get this absolute integer thing of negative 5, which is negative 5. So at negative 3, our graph would be down at -5. And we would get that one. And if we were to continue this, we would see that it does work-ish. Oh, because I did 4 instead of 5. Oh, sorry guys, I can't draw. Okay, anyways, we also want to be able to look at these in word problems, and they might not necessarily be the greatest integer function, but they're called step functions. So if we're talking about a taxi company charges a fee for waiting at a rate of 75 cents per minute, or any fraction thereof. So like, let's say I don't even wait the full minute, they're still charging me 75 cents as if it was a full minute, because a taxi driver is going to want to charge you as much as they can. So if they're waiting 1.5 minutes, they're going to round all of that up to 2 minutes. Even if it's 1.2, they're going to say, oh, that's more than a minute, we're going to charge for 2. Okay, so if I'm looking at this, anywhere between waiting 0, and 1 minute, okay, they're not going to charge for 0, so we're not going to include that, but we are going to include the 1. They're going to charge 75 cents. If I'm waiting anywhere between 1 and 2 minutes, they're going to charge for 2 minutes, which would be $1.50. If I'm waiting between 2 and 3 minutes, they're going to charge $2.25, etc. So this is what I want to be able to graph. So let's say that this is 75, this is 150, $2.25, $3. Okay, so for 1 minute, 2 minutes, 3 minutes, 4 minutes, 5, etc. Right? So for anything between 0 and 1, we said they're going to charge 75 cents. They're not going to charge for 0. At 0, they're not charging. So I'm going to put an open circle there. But at 1, they're charging the price for 1 minute. So I'm going to fill it in there. For 2, but anything between 0 and 1 minute, they're charging $1.50. So at 1, exactly 1, they're not charging up here, they're charging here. So I'm going to leave that an open circle and come over, and this is going to be a closed circle at 2, because if you wait 2 minutes, they're going to charge for 2 minutes. And this pattern continues until you get the full shape. Okay, does that make sense? Please. So yeah, that's the table of values, and if you want to see a computer-generated graph, it would look something like that. Okay, the next thing we want to look at is an absolute value function. So an absolute value, you can do this by finding a table of values, but the important thing is to start out and figure out where like the vertex is. Okay, so an absolute value looks like that. So remember, absolute value is the distance from 0. So -5 is 5 spaces away from 0. 5 is also 5 spaces away from 0. So if I were to graph the point -5, it would be at -5. If I were to graph the point 5, it would be at 5. And I get this shape. And the absolute value of 0 is 0, because 0 is 0 spaces away from 0. Okay, so first thing I want to do is I want to figure out what's the smallest, like where's my vertex going to be, the point of the absolute value function. Now absolute value is always going to give us a positive number. So that means that anything that's going to be less than 0 isn't possible. So I want to figure out the lowest it's going to be, and that's going to be when it's 0. So I solve this and I get 2x equals -2. So x is going to be -1. So at -1, that's going to be the smallest value that I'm going to have. And I want to graph it. Okay? So I make a table of values, and I want that smallest value to be about in the middle. And I want to find points on either side of it. So if I do -2, -3, 0, 1, and 2, I'm going to put these into the table of values. So -3 times 2 is -6 plus 2 is -4. Absolute value of -4 is 4. Okay, so you guys go through putting in those values for x and fill out the rest of this table. Pause your video now and do that. Once you have your table of values, you can go through and graph them. So -3, 4 would be this point here, negative 2, 2, negative 1, 0, 0, 2, 1, 4, and 2, 6. And so once you do this, you get this V shape. And this is your graph. And the last step is just to say what is the domain and range. So for this, for an absolute value, the domain is always going to be all real numbers. And the range, looking at this, it's all right above 0. So my range is going to be y is greater than or equal to 0. Okay? The next thing is a piecewise defined function. So the key to this is to graph these things in parts. So the two things that we want to graph, this line here, negative x, and this line here, negative x plus 2. So I'm going to start by graphing negative x. Okay, so remember the equation of a plus b. So the number in front of the x is the slope. So we have a slope of negative 1. I could think of that as negative 1 over 1. And I'm not adding anything to it, which means my b is 0. So it starts at 0. B is your y-intercept. So I start at 0, and then I have a slope of negative 1. So it goes down 1, forward 1, down 1, forward 1, right? And I get this line like this. But I need to pay attention to the conditions of this line. It tells me here if x is less than 0. So that means I'm not going to graph anywhere x is greater than 0. So over here, everything over here, x is greater than 0. I only want to graph it when x is less than 0. So I get this line like that, and I ignore the rest of this. Because this here isn't doesn't have that line underneath, that means the point at 0, I want it to be an open circle, like that. Okay? And then I want to go and graph my other line. So my other one, my slope, is still negative 1 over 1 because it's still negative 1 in front. But now my b is 2, which means I start at 2, and I have a slope of negative 1. So it's going to go down 1, forward 1, down 1, forward 1, and follow this. And I get this line. Kind of like this. Except here, they're saying that I want my values for only when x is greater than or equal to 0. So anything I'm not graphing, I'm only going to graph when it's greater than 0, which is going to be like this. So I can erase the rest of this. And so my final graph is going to be like this. And this is a piecewise, when you kind of have it break up and then have two different parts. Or more. You could have more than two parts. But for this case, we have two. So just a review of what functions we went over today. We went over a step function, which included the greatest integer function, which was this thing, x. And we have an absolute value function and piecewise defined function, which has like a gap and it has two different parts. Okay, so that is lesson 9.7.